Hello and welcome to helpyourmath.com. In this video, we are going to look at an application of systems of equations. In this example, we're told that 7 pears and 2 mangoes cost $17. Clearly, we're dealing with times of inflation. 10 pears and 4 mangoes cost $26. How much does 1 pear cost and how much does 1 mango cost? So based on the first two sentences, we're going to set up two equations. I'm going to use P for pear, and I'm going to use M to represent the cost of a mango. Based on this first sentence, we're told that 7 times the cost of a pear plus 2 times the cost of a mango equals $17. In the second sentence, we're told 10 pears, that's 10 times the cost of a pear, plus 4 times the cost of a mango is equal to $26. And then we want to figure out the cost of just 1 pear and 1 mango. So what we want to do here, I prefer to try to use elimination. That means to get one of either the variables, the P or the M, to have exact opposite numbers in front of them. I'm going to focus on the M because getting from 2 to 4 or from 4 to 2, which I actually could do, I won't, but I could, isn't that bad. It only requires manipulating one of the two equations. Whereas if I dealt with the P's, trying to get 7 to match 10 is going to require work on both of them. So I'm going to get that 2m to be the exact opposite of the 4m. To do that, I need to multiply by -2. So I take the entire equation and I multiply by -2, because I can't just multiply one thing in an equation. I need to use the multiplication property of equality that says multiply every term. And that's going to give us -14p minus 4m equals -34. And you'll notice I stopped using the dots, right? The dots were kind of optional. You can use them, you don't have to. It really doesn't matter. They all mean multiplication. And now what we do with these two equations, the new number 1 and the second one, is we just combine them by going straight down. 10p and minus 14p, so we look at the coefficients, that's going to be -4p. The positive 4m and the negative 4m, that makes 0. That was the goal. We wanted that to happen, so that's good. And then we say equals -8. Now to get p by itself, we'll divide both sides by -4. I'm encouraged that both things are negative. It'd be kind of weird if the pears cost negative money. And we figure out that 1 pear is $2. So that's the cost of 1 pear. What about the cost of a mango? We're halfway there. To figure out the cost of a mango, we're going to go back to either of the two original equations, and now we're going to plug in 2 for p. It doesn't matter which equation, we should get the same cost for a mango, whichever one we use. I'll use the top one, so I'm going to say 7 times 2 plus 2m equals 17. And now I'm going to solve for m. 2 times 7 is 14 plus 2m equals 17. I subtract 14 from both sides. And I get 2m equals 3, divide both sides by 2. Since this is money, I'm usually a fraction person, but just because this is money, we will convert to the decimals. And we figure out that a mango costs $1.50. So the cost of 1 pear is $2, and the cost of 1 mango is $1.50. It never hurts. I like knowing I have the right answer, so we might just check this with that second equation. So if I had 10 pears, that would be $20. And if I had 4 mangoes, well, 2 would be $3, so 4 would be $6, and that does equal 26. So I feel pretty confident that I did get the correct answers for the pear and the mango costs. This has been an example of an application of systems of equations. Thank you for stopping by.